Calculating heat of reaction from heat of formation. The standard heat of reaction can be calculated by using the following equation. This equation. This is the heat of reaction. It is equal to this equation. Now let us explain this equation. The symbol sigma, it means the sum of. So that means you have to take the total, you have to add. Now, the standard heat of reaction is symbolized with delta H, and it is equal to the sum of all the standard heats of formation, which is the symbol is delta HF, of the products. Take note of the products. And then minus the sum, that is why this is the sigma sum symbol, of all the standard heats of formation, delta HF, of the reactants. And the symbol N means coefficient in the balance equation, and that its heat of formation must first be multiplied by its coefficient. So let's go back to the equation again. Let's go back to this equation. Delta H is equal to the sum of all the delta HF of the products minus the sum of delta HF of the reactants. So N is the coefficient, multiplied it by the delta H of formation. Likewise, the N here, again, is the coefficient, multiplied by the delta HF of formation of the products. So let's go to the model problem 1. It says here, calculate the heat of reaction for the reaction coefficient 2, meaning 2 moles of nitrogen monoxide plus 1 mole of oxygen gas yields 2 moles of nitrogen dioxide gas. So the unknown is the heat of reaction, and these are the given. The formation, these are the given. The formation for heat of formation for NO2 gas, the heat of formation for NO gas, and the heat of formation of oxygen, which is 0. Free state and element, the heat of formation is 0. Okay? Take note, the unit is kilojoules per mole. The unit of heat, kilojoules per mole. So, let us now go to the equation that the delta H of the reaction is equal to the total delta H of all products of the equation. And let us go back to the equation. The equation has only one product, and this is the product, right? 2 moles of NO2 gas. And then minus the total heat of formation of reactants. So let us go back. What are the reactants? Here, the reactants. 2NO plus O2 gas. Okay, so let us substitute into the equation. There are 2 moles of NO2 gas. The equation shows 2 moles of NO2 gas multiplied by the heat of formation of NO2 gas, which is given. This is it, right? It is given. minus the total heat of formation of reactants. And let's go to the equation. The reactants are 2 moles of NO. So 2 moles of NO multiplied by the delta heat of formation of NO, which is 90.4 kilojoule per mole. This one, right? This one? Okay. Plus another reactant is oxygen, and the equation gives you the coefficient is 1 mole oxygen multiplied by the heat of formation of oxygen, this one, which is 0. Okay, so let us now do the math. 2 times 33.85 is equal to 67.7 kilojoules. Minus 2 times 90.4, this one will give you 180.8 kilojoules. And of course, 1 times 0 is 0. So, to carry out the math, 67.7 kilojoules minus 180.8 kilojoules is equal to minus negative 113.1 kilojoules. And since it is negative sign, we call it exothermic reaction. Okay? So again, there is nothing difficult in this. The equation looks complicated, but because of the symbol that you are not familiarized with yet, but later on, when you practice solving problems, you will get used to it. So let's go back to the equation. The heat of the reaction is equal to the sum of all the heat of formation of products of the reaction minus the total heat of formation of reactants. And in the problem, the equation is balanced, so the coefficients are given. And the heat of formation are also given. So all you need to do is to plug in the given into the equation. So let's go to problem number 2. So again, the equation is balanced. And the heat of formations are given again. Of course, you have to write your unknown, the delta H of the reaction. So these are given, these are given, these are given, these are given, and all you need to do is to just plug them in into this formula, that the delta H of the reaction is equal to the sum of the delta H of the products minus the sum of the delta H of formation of the reactants. And they are all given, right? All you need to do is plug them in into this equation. Plug them in into this equation. And the rest is math, right? Math. Okay? So, let us plug them in. The product is CO2. Look at the equation. The product is CO2 and H2O. The coefficient of CO2 is 4. And the coefficient of H2O is 2. So, let us plug it in. 4 moles of CO2 times the delta heat of formation of CO2 here, given, is negative 393.5, right? So, plug it in. Okay? So, when you multiply that, 4 times negative 393.5 will give you negative 1574 kilojoules. 1,574 kilojoules. And then another product is 2 moles of water times the heat of formation of water, which is also given here, negative 241.8 kilojoules. And when you multiply that, 2 times negative 241.8, the answer is negative 483.6 kilojoules. And then the equation says minus the summation of the delta HF of the reactants. So the reactants is C2H2, the coefficient is 2, and the heat of formation is positive 227 kilojoules per mole here in the given, right? Plus, and when you multiply 2 times 227 will give you positive 454 kilojoules. And another reactant is 5 moles of oxygen multiplied by 0 kilojoules per mole. And you know it is equal to 0. So to simplify the equation, negative 1,574 plus negative 483.6 will give you negative 2,057.6 kilojoules. And of course, minus 454 kilojoules. And the answer is negative 2,511.6 kilojoules. Again, it is an exothermic reaction because the heat of reaction is negative. Okay, at this time, you should have realized that nothing is difficult. Everything is given. The reaction is balanced. The formation of the reactants and products are given. All you need to do is plug them in again in the equation. Remember, it's always the total heat of formation of the products minus the total heat of formation of reactants. And do not forget that its heat of formation must be multiplied by N. And what is N? Coefficient. Okay? So let us plug in. Heat of reaction is equal to coefficient of the product CO2 is 3 multiplied by the heat of formation of CO2 plus another product is H2O. 4 mole is the coefficient of H2O multiplied by the heat of formation of H2O and minus the total heat of formation of reactants, and we have reactant, the coefficient is 1 mole of C3H8. This is the heat of formation of C3H8. Another reactant is 5 mole of oxygen multiplied by 0 kilojoule per mole of oxygen. So to simplify in math, 3 times negative 393.5 is equal to negative 1,180.5 kilojoule. And 4 times negative 285.8 kilojoule is equal to negative 1,143.2 kilojoule. Minus the total heat of formation of reactants, and it is equal to negative 103.85 kilojoules, and of course 0 for oxygen. So to simplify the equation, here we have it, okay? Minus equals positive. So that means the equation now is negative 2,323.7, and then minus is positive 103.85. The answer is negative 2,220 kilojoules. Exothermic reaction again.